Hey everybody, it's Mr. Carr again. Today we're going to be talking about 10.2, properties of rhombuses, rectangles, and squares. This is going to be more specific versions of parallelograms. So before we get into those properties, we're going to talk a little bit about the classification of our different shapes here. So quadrilaterals, which are all four-sided figures, we're going to kind of split them up into parallelograms and non-parallelograms. Okay, we'll worry about the non-parallelograms on the next lesson. So we've already talked about the parallelograms. As a recap, those have 5 special properties to them. They have both pairs of parallel sides. Okay, both pairs of opposite congruent sides. Both pairs of opposite angles, congruent, consecutive interior angles are supplementary, and diagonals bisect each other. Okay, these 5 properties were true for any parallelogram. Well, here's what's going to happen today. We can actually take parallelograms and go further. It might be a rhombus or it might be a rectangle. A rhombus is defined by having 4 congruent sides. A rectangle has 4 congruent angles. And that also means if we have 4 congruent angles, that all those angles are 90 degrees. So if I look at something that is a rhombus, since a rhombus is also a parallelogram, then I could say that a rhombus has these 5 properties plus 1 more as of right now. So that means there's 6 properties for a rhombus, and then also 6 properties for a rectangle, because it's got those 5 plus 1 more for the 4 congruent angles. A square is the combination of the two, a rhombus and a rectangle. A square has 4 congruent sides and 4 congruent angles. That's our definition there. So as of right now, there is actually for a square, there's the initial 5 plus 2 more. There's 7 properties for a square as of right now. So we're going to use those to help us with these next couple of problems. Let's start with figuring out this any rhombus RSTV, whether or not these 2 statements are true. So to start, I'm going to go ahead and draw out a rough sketch of my rhombus, RSTV right there. So rhombus has 4 sides that are congruent. Are these 2 angles congruent? Are they always true or sometimes true? In this case, it's always. The thing to be remembered about a rhombus is, like I said earlier, a rhombus is a parallelogram, which means both pairs of opposite angles are congruent. So any shape of these I look at, if I look at a square, yes, both pairs of opposite angles are congruent, or both pairs of opposite sides are parallel sides. Okay, so anything that's like true for a square is also true for a parallelogram. That's what we're looking at. So that's why this is always true. Okay, T and V though, if I look at this diagram, the way I drew it is not to, I don't want to assume that things are drawn to scale, but when I look at this one, T and V are not the same. But I don't have a never here. I have always or sometimes. T and V would be congruent if my rhombus looked like this instead. If I made my rhombus a square, now these 2 angles, T and V, are congruent. That's why this is sometimes. Okay, for this angle, these 2 angles to be congruent, it has to be very specifically when it's a square instead of my diamond shape. Okay, I'm going to classify this one right here. I want to go back to my chart and kind of look at this, but I can kind of remember that I have 4 congruent sides That's enough to say I have a rhombus. Okay, but here's the thing. When I go back here, if you're looking at classifying a shape, and you know it's a rhombus, we should double check, is it also a square? Well, to be a square, there has to be evidence that there's four congruent angles to go along with the four congruent sides. I don't have that here. If this is, since rhombus is a parallelogram, this is 70 here, this has to be 110 because those are supplementary angles. This is 70 here, and then this is also 110. So I don't have four congruent angles. So what I have is to, if I want to explain my reasoning, it's a rhombus. It has, whoops, four congruent sides, but not four congruent angles. Okay, I can show that it's a rhombus. I can't go any further to show it's a square. Got three more properties to talk about today, and that's going to be involving the diagonals of the rhombus and rectangle. So a parallelogram is a rhombus if and only if its diagonals are perpendicular. So that's a feature of just rhombuses if they are, that's a parallelogram that has this right angle in here. Okay. Also, parallelogram is a rhombus if and only if each diagonal actually, I'm going to say this instead. I'm going to change the wording of that. If the diagonals are angle bisectors. So when you look at this diagram here, angle D and B across from each other, they are actually congruent, and they're split up into two even pieces here. And this only works for rhombuses. Same thing with angle A and angle C. Those are split up into two even angles there. So I can use that to help me find these missing pieces. I know that when I look at this angle 21 and Y are going to match up. Okay. I'm told as a rhombus. I also have this as a right angle in there. So that's further evidence that I have a rhombus. So I know that Y is equal to 21. From there, I know that it's got to be 21 here and 21 here. Well, now I have a right triangle with X. X, 21, and a right angle there. So therefore, what I know from my previous properties, if I take X plus 21, that needs to add up to 90 to make this into a triangle. Subtract that over, and I get X equals 69 degrees there. Okay, so that's how we're using our diagonals to help us with some of these angle measures. All right, diagonals of a rectangle. Diagonals of a rectangle. So we have a parallelogram is a rectangle if and only if its diagonals, change that wording as well, are congruent. Okay, so that's what we're looking at in this diagram. Now, since a rectangle is a parallelogram, we also know that those diagonals have to bisect each other. That's why this part here needs to match up to this part, and this part needs to match up to that part. But since it's a rectangle, the diagonals are also congruent. So that's why all four pieces here are just the same length. Excuse me. Good timing for the bell. So that four congruent segments shows that the two diagonals are congruent to each other. So that helps us in example 4 here. It says find the measure of angle APB, which is right here, and PCB, which is down here. So APB, I'm going to go ahead and mark this. It's a rectangle, so all four sides are, or all four of these little segments in those diagonals are congruent. Well, let's look at what shape I've created here. Excuse me one second. Okay, so we're talking about this shape right here in blue. So hopefully you recognize that it is a triangle, but more specifically, it's a right triangle, or sorry, it's an isosceles triangle. So remember with an isosceles triangle, if I have two sides that match up like that, their opposite angles also match up. They're going to be congruent there. That means that this is going to be 25 degrees here. And let's call the measure of angle APB x here. So I can say that x plus 25 plus 25 is equal to 180. So my triangle facts. So solve this out. I got x plus 50 is equal to 180. Subtract that over and I get 130. For the other one, we'll call that y right now. So another triangle fact I can use, and this isn't the only one, but it's one that I can just kind of see real quick here. It's a rectangle, so I actually get a right triangle from that spot. So what I have is a right triangle with 25y, and there's that right angle. So kind of like the previous problem, I can actually set this up with y plus 25. That needs to add up to 90 to make this whole thing 180. Subtract that over and I get 65 degrees there. So that's my two angles then. We got PCB and APB. Okay, that's the biggest part. So I want you to try these. You try now problems on your own. The biggest thing on this one is just you have to make sure you are absolutely clear on these properties. So one more recap. I do want to add these actually to my original diagram as well. So what we just said too was that in a rhombus, we have four congruent sides. We also have perpendicular diagonals. And we have, when I say, angle bisectors from the diagonals. Okay. A rectangle had four congruent angles, but it also had congruent diagonals. Okay. So again, we've added on to it. Remember before I said there was 6 total properties for rhombus. Well, now there's 2 more. So if I look at a rhombus, it actually has the 5 plus 3. There's 8 properties for a rhombus. A rectangle has 5 and 2. There's 7 properties for a rectangle. A square, remember that square is a combination of a rhombus and rectangle. I didn't put any additional things for diagonals, but that's because all of this here is also true. So I'm going to go ahead and just duplicate that, and that's going to come down here. And same with this. Whoops, right there. So a square has the initial 5 right here, and it also has 5 more. There's 10 properties that apply to a square. So squares also have perpendicular diagonals. They have angle bisectors for their diagonals, and they have congruent diagonals. So all of these things are true for a square. Okay, so it's the most specific shape, but it has the most properties of it. All right, that's it for 10.2. Make sure get good practice with these, especially with all the different properties that can be tricky to find and see in different shapes. But we'll do some more practice in class on that one. All right, take care, everybody.